We will run the virtual HIL device. Now we got a HIL SCADA window. From the right side of the SCADA, we will set components from schematic editor. For source, we will define 230 volts and press enter. In the machines category, there is option to set up some initial values and machine load from the HIL SCADA. Right now, setting load from HIL SCADA is disabled. We have disabled it in the induction machine because we choose the from model. Now, in the SCADA inputs category, we can define our load. We can enable our model by typing 1. And for the reference speed, we will type, for example, 1000 RPMs and press enter. Before we run the simulation, we will click on create new panel. And now let's drag and drop capture scope tool to SCADA panel. Now we can open capture scope tool, add 4 channels and assign signals for observation. For example, we can choose VAB. Then we will observe the current in phase A, just type A. We will observe the integrator output and sign out signal. For these signals, 4 viewports will be used. Let's run the simulation. Simulation is running right now, and signals in simulation can be observed to capture scope. In the first viewport, there is the voltage between phases A and B. We can see that influence of PWM is high on the output of inverter. In the second viewport, the current through phase A is shown. In the third one, the integrator output is shown. Its waveform looks like sawtooth. And in the last viewport, signal from the sinus component output is shown. The signals are not steady, so we will use a trigger. We will trigger the current IA. Now we got a trigger point and we will fill it up a bit. Now it's a bit steadier. We can go to capture mode, take the settings from the scope and click on the force trigger. These are the signals we got. This is the voltage between phases A and B. This is the current in phase A, and this is the integrator output, and the last one is the angle for our sine block, and this is the sine out. Now we will stop the simulation, move the capture scope tool from aside, and start with making complete SCADA for particular model. From the widget library, we will drag and drop all widgets that we will use now. Knob, the slider, checkbox, gauge. Those are to observe the speed, and to observe the voltage and the frequency from the probes we will use the digital display. One for the voltage and one for the frequency. We can even use the trace graph to observe the speed and another one to observe the torque. Now we will set up all widgets. Let's double click on the knob and change the name to speed. For the minimum value, we will take 200. And for the maximum value, 1700. The step for the change can be 10. To write the Python code for the Typhoon API, we will use the code editor. Find section SCADA inputs and insert line for the speed reference. We'll click here, below the text, and insert the line of code. Of course, instead of this 0.0 reference, we want to use the input value of the knob, that is input value. We will save the changes and close. This is what we got. We will use the slider for the torque load. The minimum value is 0. And the maximum value will be 5. Step for the low will be, for example, 0.2. And we will do the same for code editor. We will insert the line for the load, and the situation is the same. We will change 0.0 to input value. And save everything. Now we have got a slider to change the motor load. We will use the checkbox to enable or disable controller and the inverter. In this case, we will remove these two lines after IF input value and else. We will open the code editor and insert the line for enable. Click on insert, and if it is checked, we will set the value of 1.0. Copy this line, paste it after else, and if it is not checked, it will be 0.0. We can save the changes and close wizard window. Before closing property window, change the name of the checkbox into on/off. With the gauge, we would like to observe the speed. Let's rename it to speed. From the analog signal property, we will find signal speed. Of course, in the advanced settings tab, we will change the range. It will be between 0 and 1800. Close the window and make it wider. With the first display, we would like to observe the voltage. Let's rename it to voltage and set analog signal to voltage. Press enter and we can close this window. We will change the name of the second display into frequency and find the analog signal frequency. Press enter to remove the red color and click OK. In this graph, we want to observe the speed. And we want to change the scale into a range between 0 and 1800. In the second graph, we will observe torque and load. Analog signal will be torque. We will change the range to be between 0 and 6 and close everything. That is it. We can set the reference speed, enable PWM and run the simulation. That is all we have got. We can control the speed. We see that it is raising, as well as the voltage and the frequency. If we turn up the speed, we see that the frequency is above the rated frequency, but the voltage is fixed and constant at 230 volts. We can lower the speed and, for example, turn on the load. Now we made the load higher, the speed drops a bit, but the PI controller is trying to keep the speed constant. If we change the speed reference to lower one, the voltage and the frequency will drop. We can add a lower load to make the motor almost unloaded. For example, this period in which the load dropped, the speed raised a little bit.